Dear students, welcome to this MOOC. MOOC stands for Massive Open Online Course. In this MOOC, we shall be providing you a variety of multimedia enriched e-content, activities and assessments in a very learner friendly manner so that you are able to understand the various topics of this course very well. Let me now tell you briefly about the structure and main features of this MOOC. The entire MOOC has been divided into various weeks so that you can plan your learning in a very logical and systematic manner. It is advised that you must actively participate in the various components of this MOOC, that too regularly on a weekly basis. For every weekly schedule, you are first advised to watch 2 to 4 videos assigned to you per week. Then you must read the learning material provided as e-text and also go through other content in the Learn More section. After this, you are advised to carry out the various activities like taking part in the discussion forums, visiting the related web links which we have provided for you, attempting crosswords, etc., earmarked for each week. After this, to test your knowledge of what you have learned during this week, you must attempt the quiz in the assessment section for that particular week. I wish you all the best in this very interesting self-learning experience. Please remember, we shall always be there with you to provide you support for any problems you face. The MOOC coordinator along with junior faculty as tutor shall always be available to solve your queries which you can post in the discussion forums or you can send them to us through mail which shall be notified to you soon. We would be very happy to know your experience after the completion of this MOOC in the form of your feedback which will help us enhance the quality of this MOOC further. So dear students, after knowing the overall structure of this MOOC or the online course, let us now go into the details of what all you will study in this course on organic reaction mechanisms part 1. In this course, we have tried to give you an overview of the different types of organic reactions, and this course will cover the reaction mechanism of some very important organic reactions with a focus on different types of substitution reactions, namely aliphatic nucleophilic substitution, aliphatic electrophilic substitution, aromatic electrophilic substitution and aromatic nucleophilic substitution. But before we go into the details of these, we have to have an overview of the types of organic reactions and mechanisms in general. So, in keeping this in mind, the initial 3 weeks will be focused on revisiting what you have already studied, but we will be taking it in more depth. So, dear students, in the first week, we shall be giving an overview of the different types of organic reaction in detail. In organic chemistry, you are already aware there are different types of reactions which are substitution, addition, elimination, oxidation, reduction and rearrangement. In the forthcoming second week, factors affecting these different types of reactions shall be discussed. There shall be discussion on the intermediates or the transition states which are involved, as well as on the potential energy diagrams and the various methods of determining the mechanism. In the next week, which is the third week, the focal point of discussion shall be the generation, structure, stability and reactivity of important reactive intermediates. So, one module each will be devoted to this, that is carbocations, carbanions, free radicals and carbenes and nitrines. So, dear students, keep in mind that these first weeks shall form the basis for the understanding of not only the topics which will be covered in the later part of this course, but also many other reactions of organic chemistry. So, it is very important that you should study these thoroughly. After this, moving ahead with this course, in the 4th week we shall study about the linear free energy relationship, Hammett equation, substituent and reaction constants which form the basis for calculation of various factors for a reaction. The study of aliphatic nucleophilic suction will begin in 4th week with SN1 and SN2 reactions, that is unimolecular nucleophilic suction and bimolecular nucleophilic suction reactions, and we will continue this in the 5th, 6th, 7th and 9th week as well. Mixed SN1 and SN2 reactions along with a single electron transfer, that is SET reaction, shall form the basis of discussion in the week 5th. After this, we will move to another concept which is neighboring group participation. So, neighboring group participation and enchimeric assistance of groups shall be discussed in the 6th week. Here we will see how the interaction of a reaction center occurs with either a lone pair of electrons in an atom or the electrons present in a sigma bond or pi bond. So, the next topic we will be studying in this course will be neighboring group participation, and if we talk about neighboring group participation and enchimeric assistance of groups, we will be studying them in detail in the 6th week. And here we will see how the interaction of a reaction center occurs with either a lone pair of electrons in an atom or the electrons present in a sigma bond or pi bond of the group. And this neighboring group participation will be discussed keeping in mind the aliphatic nucleophilic substitution reactions. After this, the 7th week will take you to the internal nucleophilic substitution, that is SNI reaction, and other parameters of aliphatic nucleophilic substitution reactions like nucleophilic substitution at an allylic, vinylic and aliphatic trigonal carbon. You shall also become familiar with the reactivity effects of a substrate, attacking nucleophile, the leaving group and reaction medium, as well as the effect of ambident nucleophiles and the regioselectivity involved. Week 8 shall be actually a revision and assessment week for you. No new content will be provided. In this week, you are supposed to revise what all you have learned in this course and submit the assignment in time. Please note that the marks obtained by you in these assignments shall be counting towards your grades in this course. After this, we shall move to the week 9, and in week 9 we will be talking about the carbocation rearrangements. You know, carbocation rearrangements, they play very significant role in aliphatic nucleophilic substitution. So, here the focus will be that how these common carbocation rearrangements occur, and we will also take you to what are non-classical cations. And after this, we will be studying about two techniques to accelerate the organic reactions, which are phase transfer catalysis and ultrasound. The next detailed study shall be on aliphatic electrophilic substitution reactions, and this will be covered in the 10th and 11th weeks. In the week 10, the mechanistic details along with suitable examples of different types of electrophilic substitution reactions, that is SC1, SC2 and SCI shall be discussed. The 11th week shall deal with the factors affecting electrophilic aliphatic substitution reactions and emphasize on some of the substitution reactions which are accompanied by the double bond shifts. After the 11th week, we move to the 12th and a part of 13th week, which shall be devoted to the detailed study of electrophilic aromatic substitution reactions along with some exemplary named reactions like diazonium coupling, Wills-Mayer reaction and Getterman-Koch reactions. Remaining part of 13th week and continuing this to 14th week, this will be focusing on aromatic nucleophilic substitution reactions, along with some exemplary named reactions, and this shall include SRN1 reactions, reactivity effect of substrate structure, leaving group and attacking nucleophile. The named reactions that will be discussed here are von Richter reaction, Somlet-Hauser reaction and Smiles rearrangement. Coming to the end of the course in the 15th week, dear students, again it will be a self-study week for you, and in this week you are supposed to revise what we have learned in the entire course, and again we will be giving you assignments which you have to submit in time, and need not mention again that yes, they will be again counted for your grades. So dear student, I am very confident that this course will equip you with the knowledge about the different types of substitution reaction along with their mechanistics and other details. After the completion of this course, there shall be a proctored examination about which you shall be notified at appropriate time. And I am very sure that you will find this course very interesting and enjoyable. Please go through the entire e-content, which includes both the self-learning videos as well as e-text very thoroughly, and perform all the activities and assignments of this course sincerely and in time. I am quite confident that going through this course shall be a great self-learning experience for you. I wish you all the best.